Okay, we'll be looking at section 10.3, problems 1 through 9 right now, and then later on we'll do the other problem set. Okay, so I'm also doing my own recording now, so that might be a little jittery holding it in my own hand. But as you can see in this section, what we're doing is we're looking at radical operational expressions, adding and subtracting in this first set of problems. And when we do this, it's similar to what we do when we have fractions. And what we need to do before we can add or subtract fractions is get a common denominator. Similarly here, we have to get a common radical. And we do that in 3 steps. First of all, we factor out all the terms and the radical terms in the expression and identify what the common radical is, then perform the operation and simplify. So let's go to problem number 1. 2 square root of 5 minus 4 square root of 5. Well, here you can see 5 is the common radical, so I don't have to do anything. Just do my arithmetic operation. 2 minus 4 gives me minus 2 square root of 5, and that's the answer. Similarly, for number 2, square root of 7 plus square root of 7. Well, 7's already my common radical, so I don't have to do anything. Add them together, 2 square root of 7. And again, with 3, we have 3 square root of 6 plus 2 square root of 6. Square root of 6 already the common radical. And I just add them together to give me 5 square root of 6. For number 4, first time we have to actually do a little work here. So let's look at it. 5 square root of 2 plus the square root of 32. So what I did here is I pull out the prime factors. And so the square root of 2 stays the same. But for the 32, that's 5 2's. And I've written them over here. I've parenthesized off pairs because I know I can pull those out of the radical sign. That's what I've done here in this second term. So I get 5 square root of 2 plus 2 times 2 square root of 2. So it's 5 plus 4 gives me 9 square root of 2 is the answer. In number 5 here, I've got 3 square root of 3 minus the square root of 75. So again, I go over here and I've factored out, okay, 3 stays as it is, but 75 becomes 3 times 5 times 5. And I've written them again in parentheses for the pairs because I know I can pull those out of the radical sign. So I have 3 square root of 3 minus 5 times the square root of 3. So it's a 3 minus 5 gives me a minus 2 square root of 3. Going to number 6, 4 square root of 54 plus 2 square root of 24. So again, I'm going to factor out the terms. And I've done that in here. Then in this step, I've indicated whether the pairs are, so I can pull those out. So I have 4 times 3, square root of 2 times 3. 2 times 2, square root of 2 times 3. So that's a 12 plus 4, square root of 6. And that gives me 16 square root of 6 is the answer. For number 7, 10 square root of 5 minus 5 square root of 20. So again, I go over here, 10 square root of 5 stays as is, 5 is a prime. I can factor out the 20 is 2 times 2 times 5. So I have 10 square root of 5 minus 5 square root of 2 times 5, which I've put in parentheses because they're a pair. So I have 10 minus 10 gives me 0. Going to number 8, 2 square root of 8 plus the square root of 200. Again, factoring out those terms, 8 is 2 times 2 times 2. 200 is 2 times 2 times 2 times 5 times 5. I've paired off the things in parentheses again, and I can pull those out of the radical expression. 2 times 2 square root of 2 plus 2 times 5 square root of 2. So I got a 5 plus a 10 gives me 14 square root of 2. Going to number 9. 3 square root of 12 plus the square root of 108. Again, factoring those out, 3 times the square root of 2 times 2 times 3 plus the square root of 2 times 2 times 3 times 3 times 3. Pairing them up there, and then pulling them out of the radical sign leaves me with 6 square root of 3 plus 6 square root of 3, which of course is just 12 square root of 3. And that completes this first problem set. I'll do the next set in a second.